Okay, so some different changes here. I heard first period didn't get the review, so you should have gotten it before this video. If not, your sub should be giving it to you right now. Definitely want to make sure you get a hold of that. And I am making it to where your team test at this point, you should know, is going to be tomorrow. Hopefully I'll be back by tomorrow. If not, I will change things around again. So you guys can take the team test with me. And then this lesson that we're doing is starting the next chapter. And honestly, no, it's not a great lesson for me to just talk to you and tell you what to do. But also, you guys taking out mirrors and stuff for this lesson is not a good idea either without me there. So, with all that being said, I am fully aware this is not how it's supposed to be, but when making decisions, I thought it would be best for me to be with you when you're taking your team test. So, we're making some sacrifices. It's not a big deal in this first lesson that you're not actually doing the activity. It's a fun one, but we've played with mirrors before, so no worries on that. Okay, so now let's actually get to it. 714, using symmetry to study polygons. Oh, last thing, sorry. Friday, you'll be getting your course recommendation forms, and on Tuesday, we'll be talking about that in class. So I'll just let you know what I recommend, and we'll talk through all of that. So that would be like the main focus, and obviously getting everything wrapped up from anything that I missed this past week. Okay, so 740. I'm going to read this. You're not going to do it. I'm just going to tell you what the answers are. Below are 4 challenges for your team. Each require you to find a creative way to position the mirror in relation to the colored paper. You can tackle the challenges in any order, but you must work together with your team on each of them. Whenever you successfully create a shape, do not forget to measure the angle formed by the mirror, as well as draw a diagram on your paper of the core region in front of the mirror. If your team decides that the shape is impossible to create with the hinge mirror, explain why. So we've done stuff like this before where we're like putting the mirror down on like a piece of paper, and then we look in the mirror. So here you're like specifically creating shapes, and this chapter is going to be all about shapes and their definitions and attributes. So this one is just kind of getting you warmed up to that. So looking at the first thing that you were supposed to create is a regular hexagon. So regular means, oh, that's a eraser. Regular means all equal sides, and we should know this, and all equal angles. And then hexagon means it's 6 sides. So the top view and stuff is gonna look, it would look like this, like if you're looking into the mirror when you create it, it would look like a hexagon, obviously, because that's what you're trying to get. So draw that. And then when you're looking at like, since you have the mirror like this, it cuts it up into little triangles on the inside. So these are the way the little triangles are cut up. And obviously mine would look a little cuter. But the angle formed is like this angle right here. So like this is your mirror right here, and then like you're looking inside and like all the other pieces are reflections, and that's how it's creating that. But the angle formed is this angle right here. So you would actually measure it in this one, but there is also another way to find that angle without measuring it, and that's kind of like what this lesson is getting at. If you think about the center piece, there's all these pieces should be the same because it's a mirror image. So all those triangles are equal, and then we know that all of them together should create 360 because it's a circle. So to find this missing angle right here, I would do 360 divided by 1, 2, 3, 4, 5, 6 of them. And again, this would have been done a different way, but you know, gotta do what we gotta do to get that team test done together. So 360 divided by 6 is 60 degrees. So this angle right here is 60 degrees. And then the next one says create an equilateral triangle. So equilateral means equal sides. So this one will be all the sides are equal here, and then in the center is where you're connecting like this. So that's not a bad triangle if I'm just like, you know, saying so myself. So same process here of the idea that the mirror pieces were here and then all the rest are reflections, and this is the angle we're trying to figure out what it is. So it's still a circle. We got 1, 2, 3 equal pieces this time. So we're gonna do 360 divided by 3 because we have that mirror, so it's 120. Love this lesson as an actual activity. Bummer. And then it says create another equilateral triangle in a new way. This one's kind of hard for people when we actually do it, but what you can do here is instead of doing these big isosceles triangles, is you could cut it in half and use your mirror like this with like a little right triangle. So that's the way it's gonna look. So here's our equilateral triangle again, and then this one it gets cut up the same way, but then everything was like cut in half. So I'm just gonna draw and then you'll see. Oh my gosh, I was made to do this today. So our mirrors are here, our pieces. So to find this angle, they are still all equal triangles because it's a mirror. So 1, 2, 3, 4, 5, 6. So we do 360 divided by 6, and that will give us 60 degrees. So a little side note, it's a 30, 60, 90 because that's 90 and then 30 would be down here. But no biggie, no biggie. Just something we learned before. Okay, and then nope, there's more, JK. 2 more, create a rhombus that is not a square. So a rhombus has 4 equal sides, and then to make it not a square means no right angles. So I'm gonna draw me one. The way that it kind of looks like a parallelogram. I'm so very sorry. The way I show people to do this with mirrors is start with a square and then they kind of like pull over the mirror. I know that doesn't exactly make sense because you don't have it right in front of you, but the way it'll look is like this. So your mirror is kind of like slanty, like this is shorter than that one or vice versa, however you draw it. So here's my angle. These angles will still be the same in the middle, even though it looks a little weird. So 1, 2, 3, 4, because again, it's a mirror. So 360 divided by 4 is 90 degrees. And then the last one is create a circle. And we've done this before where we're trying to create a circle with our mirrors, and it's not possible because you're always going to get some kind of side length, even if they're very, very, very tiny and it's like hard to see to the eye because they're so small. It's just not possible. So, because what this is getting at here is that circles and other shapes, polygons in particular, are not in the same realm, like they're not the same thing, and sometimes they think we forget that and we kind of like throw them in the same place. So yes, there you go. Okay, so now that we have this, the next part says 741, how can symmetry help you learn more about shapes? We kind of already started this together, so awesome, you already know the answers to all this very soon. It says discuss each question below with the class, aka I'm gonna talk about it by myself. I hope you're laughing at me laughing at myself right now. That would be great. Or you could just be staring. But A says one way to create a regular hexagon with a hinge mirror is with 6 triangles as shown below in the diagram. Bam. Which we already did up here. Bam. Think it's pretty much the same pick. Now I've got all this stuff to erase. Hold on. And then it says, note the great lines represent reflections of the bottom edges of the mirror and the edges of the paper while the core region is shaded. So basically it's just saying like, this is your actual mirror. These are all the reflections inside the mirror, like if you were to look inside. And then the darkened part is like the paper you would have set it on. So then it says, what is special about each triangle, the diagram? What is the relationship between the triangles? You would have discovered this by yourself, but here we are. We already answered this. Each of the triangles are the same because you have those reflections in the mirror. The triangles are the same. So then it says, would it be possible to create a regular hexagon with 12 triangles? So this is actually getting at the idea that we did between these two, in the sense that we are going to see if we can just like split everything in half here. So 2 triangles, 4, 6, 8, 10, and 12. Yes, that'd be possible by just splitting every triangle in half. So now the mirror is just in this piece. So then I've got all those little triangles. So yes, each triangle can get split in half. And then you can also think about it numerically speaking. If you're thinking about 360 divided by the 6 original triangles, and you've got 60 degrees, and then if you want to do 360 divided by 12, you would get 30 degrees. Yeah, 30 degrees. Okay, so then B says, if you're not already done so, create an equilateral triangle is that the core region in front of the mirror is a right triangle. We did that together. Draw a diagram of the result. So we're just going to draw that again. And I kind of like ruined all the surprises for today already, but that's okay. Oh man, these are just amazing picks that I'm doing. So then it says what special type of right triangle is in the core, and I've already talked about this, but we did 360 divided by 1, 2, 3, 4, 5, 6 to find out that middle triangle there. So 360 divided by 6 is 60 degrees. So then, okay, let's see if I can get rid of, these little dots that I just threw in there. Nope, not looking good. Hold on. So then I'm going to put that in here. Struggling here. So that was 60 right here. And then this is 90. And then that makes this piece 30 because 180 minus 60 minus 90 gives us 30 degrees. So it's a 30, 60, 90, and I know you love this special right triangle so much. But there's some special things that we know about that in terms of figuring out pieces. So this is x, this is 2x, and x squared root of 3. It's just lovely, I know. And then the next part, it says, can all regular polygons be created with a right triangle in a similar fashion? Yes. Okay, see, it says in problem 740, your team created a rhombus that is not a square. Draw a diagram like the one above that shows how you did it. So we're just copying that picture again. Oh, almost, so close. So then it says, how can you be sure the resulting shape is a rhombus? Use what you know about the angles in the mirror. So what it's getting at is how can we be sure that it has 4 equal sides? Because it is a mirror, everything is mirroring itself. So like thinking about the fact that this piece would have to be the same as this piece and this piece and this piece, because when you're doing your reflections on your mirror, it's going to literally reflect it and copy and paste that information. So then the next part, it says use what you know about the angle of the mirror. Explain what must be true about the diagonals. So Just as a reminder, diagonals are, I don't know if we've talked about diagonals yet, but just if I'm thinking about a shape, a diagonal is that piece right there from one corner to the other. We might have talked about it. So when it's talking about these diagonals, we know that this piece and this piece are different. So then when you're looking at the mirror, then that is going to be this piece and this piece, copied and pasted. And then the last question, it says, use what you learned today to answer the question below. Examine the regular octagon, so that's 8 sides. What is the measure of the angles? So you just need to do 360 divided by 8. 1, 2, 3, 4, 5, 6, 7, 8, just in case we did that wrong. And then you would get 45 degrees. So hopefully you have a lot of time to work on your Chapter 6 review if you didn't get it yesterday. Sorry about that. And then just a heads up again, all of the answers and work are on Schoology via video and just like a PDF. So make sure you're checking that out for the team test tomorrow.